Okay, we are asked to prove this identity right here. And we do that by transforming one side to make it look like the other side. You have some very explicit directions here to transform the left side to make it look like the right side. And that's usually what you do, work on the complicated side and simplify. Okay, so the directions are to get a common denominator for these two fractions and combine them into one fraction. So the common denominator is tangent theta times 1 minus secant theta. So this first fraction needs to be multiplied by 1 minus secant theta in the numerator and denominator so that we end up with the common denominator. And similarly, the second fraction needs to be multiplied by the tangent of theta. So there we have a common denominator. And we're going to do the subtraction to form one fraction. While we're at it, let's multiply 1 minus secant theta. We could have written this as the quantity squared. But squaring that binomial gives us 1 minus 2 secant theta plus secant squared theta. And then minus tangent theta times tangent theta is tangent squared theta. At this point, we're told to use a Pythagorean identity to simplify the expression. You might wonder how we're going to do that. The idea, if you focus on the target, is that we want to end up with 2 cotangent theta. So all these secants are disappearing. So we got to get this 1 minus secant theta to cancel out. That tells me that we're going to replace tangent squared theta using this Pythagorean identity right here in slightly different form. Tangent squared is equal to secant squared minus 1. And that's what I've written right here. Now, if I remove those parentheses and combine similar terms, secant squared minus secant squared cancels out. This minus a minus 1 becomes a plus 1. And so I get 1 plus 1 is 2 minus 2 secant theta. That's what's in the numerator. Factor out the 2. And now we can see what's happening. These factors cancel out. And we've got 2 over the tangent of theta. We want it to look like this. So we're going to use a reciprocal identity. We're going to replace tangent theta with 1 over the cotangent of theta. And then if I perform that operation, 2 divided by 1 over the cotangent of theta is 2 cotangent of theta. And that's identical to what we started with on the right side. So QED. Got to give some kind of indication that you're done. Some teachers let you just put a smiley face at the end of your proof. Okay, so to go from here to here, we use a reciprocal identity. Tangent of theta equals 1 over the cotangent. There you go. Hope that helped. If you have any questions, post a comment.